In this video, we're going to look at solving radical equations. These are equations that have radicals in them. Your first step is going to be to isolate the radical. Then you want to take the radical term and raise it to the power of whatever you need in order to undo that radical. So it's going to be raised to the power of the index of that radical. You're going to raise both sides of the equation to that power. That's going to undo the radical. You'll solve, and then you do need to check for extraneous solutions by plugging your solution back into the original equation. The square root of x plus 13 equals x plus 1. So to undo the square root of x plus 13, we're going to square both sides. So on the left-hand side, now we just have x plus 13. And on the right-hand side, we're going to write out x plus 1 squared as x plus 1 plus times x plus 1. I always like to write that binomial twice to avoid the very common error of trying to distribute that square, that exponent. We have to FOIL this out. So x plus 1 times x plus 1, this is x squared plus 2x plus 1. We can see that this is a quadratic, so we're going to set it equal to 0. So we've got x squared, 2x minus x is x, and 1 minus 13 is negative 12. We're going to factor this. Factors of negative 12 that sum to positive 1. It's going to be positive 4 and negative 3. And if I were to set each of these factors equal to 0, we would get x equals negative 4 or x equals positive 3. But we have to check both of those solutions. So first checking x equals negative 4. I've got the square root of negative 4 plus 13 equals negative 4 plus 1. So negative 4 plus 13, that's going to be 9. The square root of 9 is 3 equals negative 3. This is not true. So negative 4 is not a solution. Now let's check x equals 3. We have the square root of 3 plus 13 equals 3 plus 1. 3 plus 13 is 16, and the square root of 16 is 4 equals 4. That is a solution. The square root of x plus 2 equals the square root of x plus 10. So in this particular example, we have two radicals. So we're going to end up having to isolate the radical twice. We're going to start this process by trying to undo a radical. We're going to undo the radical on the right-hand side by squaring both sides. But what we'll see is that when we square the left-hand side, we're going to still end up with a square root. So we're going to end up isolating one more time. So we've got the square root of x plus 2 times the square root of x plus 2 equals x plus 10. Being really careful to FOIL the left-hand side, the square root of x times the square root of x is x. This is going to be plus 4 square root of x plus 4 equals x plus 10. Start combining like terms. We can subtract x and 4 from both sides. So we have 4 square root of x is equal to 6. You can divide both sides by 4. The square root of x is 6 over 4. And now this is where we're going to, basically, we've isolated the radical again. We're going to square both sides again to undo that square root. X is equal to 36 over 16, which will simplify to 9 over 4. We do need to check that answer, though. We always need to check our solutions. We have the square root of 9 over 4 plus 2 equals the square root of 9 over 4 plus 10. The square root of 9 over 4 is 3 over 2 plus 2 equals the square root of 9 over 4 plus 10. If we find a common denominator of 4, this is going to be 49 over 4. Looking at the left-hand side, 3 over 2 or 3/2 plus 2. This is, if we get a common denominator, going to be 7/2 equals, and now the square root of 49/4 is 7/2. So that solution is correct and not extraneous.